In this video, we're going to have a look at defining trigonometric ratios for angles between 0 and 360 degrees. So, defining trigonometric ratios. Okay, so those sine, cos, and tan, right, for angles between 0 to 360 degrees. Okay, this is quite important, especially when we start looking at the applications of trigonometry on the Cartesian plane and looking at angles that are bigger than 90 degrees. Okay, so let's have a look and see. So I think the best way to explain this would be basically to have a look at a diagram. Okay, so let's have a look at a diagram. Okay, so if we have, let's say if we have a point P, okay, with a coordinate x and y, right, and we create a circle, okay, with a radius equal to r. Okay, so if we have a look at something like this in terms of a diagram, right, let's draw something here. Okay, and then we have our line coming down here, okay, with your point P, x and y, and your coordinate would have a radius of r. So obviously this is going to be a circle. Alright, so we've got a circle there. Let's see if we can convert this into a refined shape, whether this will work here. Okay, that looks a bit better. Alright, so if we draw that point in again, okay, that would be the point PXY. Okay. Okay, perfect. Okay, and that obviously has a radius of r. So that's your origin, that's your y-axis, and this is obviously your x-axis. Okay, so if we had to close this off and make it into a right angle triangle here, and put in the theta. Okay, so this is obviously the angle that we're working off of, okay, in our triangle. We see that if you have a look at okay, if this is point P and it has a value of x, then we would know that this base of this triangle has a length of x. Okay, or that would be the, remember we said adjacent. Okay, and then we've got obviously a hypotenuse here. Okay, and then we've got the opposite side. So the opposite side would then have a value of y. So in terms of its length, okay, it's y, and that's obviously our opposite side. All right, so if we have a look now and we look at the trigonometric ratios for this quadrant, so obviously this is your first quadrant. Okay, this is your first quadrant. Okay, so if we evaluate the trigonometric ratios, we see that sine of that angle theta would be the opposite over the hypotenuse, which would provide y over r. Okay, and the cosine of theta would be your adjacent over your hypotenuse, which would produce x over r. And your tan of your angle theta would produce y over x, which is your opposite over your adjacent. All right. Okay, so some things to note here is that, as I've said previously, okay, r is always positive. So r is always positive. Okay, and okay, so if we're going to look at the this P in different quadrants. So we're going to look at it in quadrant 2, 3, and 4 as well, the behavior of X and Y. And so we will notice that the signs of the coordinates of P change as you move to different quadrants. All right, okay. Okay, so another thing to note, okay, is that we always measure the angle theta. Okay, so theta is measured, right, from the positive x-axis, So what I mean in saying that, okay, is that if this is your x-axis right here, okay, and this is your y-axis, okay, well, I think the y-axis is irrelevant here, but I'll just put it in. So, and let's say your triangle basically has a line like that, okay. So let's say for instance this is your triangle here, okay. So that's your triangle right there, okay. Remember that your angle or your theta is measured from the positive x-axis. So we're going to start here, we're going to arc, okay. So this would actually be your theta if you think about it, okay. Although you draw the theta in here, okay, this is actually your theta right here, okay. So to make up for this discrepancy, or orientating, if we can say, orientating the theta around in different quadrants, we make use of something called reduction formula. Alright, so that's basically looking at them in different quadrants. So if we had to understand here, okay, that we're dealing with quadrants, so this is 0 degrees, okay. So when you start off here, you're on 0, okay. So as you move through from 0, okay, all the way around to here, okay, at this point here, from 0 as your reference, you've moved 90 degrees, okay. And further to this, you move again, come down here, okay. Now from 90, you've moved another 90, so you're on 180 degrees, okay, in terms of from where you've started, okay. And if you move again another 90 degrees, from 180, you've moved 270 degrees. Alright, so sitting at this point here, you've moved 270 degrees from the origin, from the reference point, this reference point right here. And if you move another 90, okay, move another 90 from the 270, you come back to where you started from, okay, and that would be the positive x-axis. So you're basically ending on 360 degrees from where you've started, okay. So it's very important to understand these different reduction formulae, if we have to put it that way, okay. So what we're going to do now is we're going to show you the different quadrants and how the signs of P changes as you move through across. All right, so let's look at the second quadrant. Okay, we're going to have a look at the second quadrant now. If we had to draw a 90-degree triangle in the second quadrant. So I've got a sketch here. So that's your X and that's your Y. That's your origin. Okay, so That's your triangle right there. Okay, this is on the origin, and there's your 90 degree. Okay, so we're going to call this point P again. All right. Okay, so just remember this lies on that. This lies on that same circle. Okay. Alright, that lies on that same circle right there. And basically this has your same radius r, and this is your p. But this time, remember, the coordinates of p would be negative x, because you're on the minus x-axis, and it would be positive y. Okay. So going ahead right now and understanding, okay, that your value here, okay, is actually minus x, and your value right here is positive y. So as I've said earlier, okay, to get to this quadrant, okay, or to work out this little angle in here, okay, to work out this angle in here, you're actually measuring from here. So as we've said earlier, this is your actual angle that you're going to put into the trig ratios. So if you're working with an angle here, okay, let's put that in green. So if you're working with this as your angle that you're working off of, okay, you're actually reducing it. So to find out this angle, okay, so everybody knows angles on a straight line, some 180, okay. So if we take off this piece, if we want this piece here, okay, this is our angle that we have, we actually need to say, what do we actually need to say? We actually need to say 180 degrees minus that value. That's what this value here would be. Okay, so if this value is, say, let's say for an example, if theta, say, is, let's say, 80 degrees, okay, then we know from basic math that we would get 180 minus that 80 degrees, which is 100. So this is actually the angle that we're measuring off of, because we're using that same angle in the second quadrant. Okay, so coming down and actually writing the trig ratios here, we see that sine of 180 degrees minus our angle theta is equal to, what would it be equal to? Right? So sine of 180 minus, okay, is going to be equal to your y value. So it's going to be, remember, sine is opposite over hypotenuse, so it would be, this would be your opposite side. Okay, let's put that in. This would be your opposite side. Okay, this would be your adjacent side, and this would be your hypotenuse side. So it would be your opposite side, okay, which is your y, over your hypotenuse, which is r. Okay, and then we see that that's the same thing as, if we look at the previous slide, we see that that's the same thing as this. Okay, so what it means is, right, what it means is that this sine of 180 degrees minus theta is actually equal to just sine of theta, okay, because it maintains the same ratio. All right, let's have a look at cosine now. So cosine of 180 degrees minus theta would be, okay, so remember that is adjacent over hypotenuse. So adjacent now would be minus x over r. Okay, so minus x over r, just remember that's negative, and x over r, remember, was the same thing as cosine theta. So we've got minus cosine of theta here. So this is the same ratio as cos of theta, okay, but it's just negative this time around. Okay, let's make this a bit smaller here so that we can put in 10. Perfect. Okay, so now if we had to look at tan of 180 degrees minus theta, okay, we would see that that is equal to, so remember tan is opposite over adjacent, that would be y over minus x. Alright, and that's the same thing as tan, just that this time it's negative. Okay, so we've got sine being positive, and just a note here that sine stays the same, it's just cosine and tan that have changed signs. Okay, so just an important thing to note here. When we've got our triangle in the second quadrant, cos and tan become negative and sine stays positive. Okay, so let's just write quadrant 2 on the top here. So we've got a reference, quadrant 2. Alright, so we're going to have a look at quadrant 3 now. Alright, let's have a look at quadrant 3. Okay, so let's have a look at quadrant 3. Alright, so we've got our axes like so. It's always important to label your axes. Okay, you've got your point P. Alright, and then let's close that off. Okay, right angle R. Remember, R is always positive, and we can attempt to draw a circle in here. Okay, so something like so. Circle doesn't look too great. Okay, just imagine there's a circle here. Just imagine it's a perfectly round circle. Okay, that goes all the way up there. Let's take this off. That's why. Alright, okay. So forgive my drawing skills here. Alright. So if we had to look at now the coordinates, okay, of this point P, alright, it's going to be, alright, remember we're sitting on the negative x-axis right here. Okay, so it's going to be minus x firstly, and we're also on the negative y. So we are essentially below the origin, so we on the negative y. So we see that the coordinates of P are negative for the x and for the y. So if we put that into perspective, this is negative x, alright, and this is negative y. Alright, so if we continue here and we do the same thing that we've done previously, okay, just to show you that reflex angle measured from the positive x-axis, okay. So if this is your angle in here, okay, you're actually looking at, alright, when you start off from the positive x-axis, remember, so you're starting off here and you're going all the way down to here, alright. So if you have this, right, let's draw it off on the side here. So if you have a straight line here, okay, remember the angles on the straight line are 180 degrees. If you've got another line coming down there, remember that you go all around from here all the way around to there. Okay, so if you think about this being 0 degrees, and obviously then you got your 90 here, okay, and here this is 180 degrees. When you're on here at this point, when you're here, this is 180 degrees plus theta. Alright, so just remember for the third quadrant, we're 180 degrees plus. This is what we are sitting on. So if we had to write our trig ratios down for this instance, we see that sine of 180 degrees plus theta would produce, it would give us minus y, because remember, if we label our triangle, okay, in terms of our Sakatoa, let's use a different color here, let's use green. So this would be the opposite side, okay, This would be the adjacent side, and this would be the hypotenuse side. So coming down here, okay, so sine, that would be minus y over r, okay, which would be minus sine of theta. Okay, so it's the same thing, all right, as sine. It's just that this time it's negative. If we do the same thing for cosine of 180 degrees plus theta, we see that we would get, okay, that would be adjacent, which is minus x, over your hypotenuse, which is r. And that would give us a negative cosine of theta, all right. And if we have a look at the tangent ratio, okay, you can see that right here. So tangent of 180 degrees plus theta would now give us, okay, opposite, which is minus y, over the adjacent side, which is minus x, which would just cancel off, right? Remember, the negatives would cancel here and just give us y over x, okay, which is the same thing as positive tan theta. All right, so just a note here, okay, you've got these two as being negative, all right. You've got the sine, or you've got the tan as staying positive, okay. So if we had to use the same notation there, this one stays positive, all right. What did we use for the negative ones? We use red, okay. And you've got these two as becoming negative. All right, let's finish this up by looking at quadrant 4. Okay, so looking at quadrant 4 now, okay, so if we draw a diagram here again, let's draw this a little bit higher up here. Okay, so that would be x and that would be y, would be origin. And if we had to draw a point in here, okay, remember this radius was r, and that point P now would be, okay, what would it be? All right, remember we said initially it was going to just be x, okay, so that would be a positive x because we are on the positive side of the origin in terms of the x-axis, and in terms of the y-axis we're still on the negative side. You see, we're still on the bottom end here, so that would be minus y. All right, so if we draw the circle around again, okay, if we draw the circle around again, just a bit longer. Okay, please forgive my circle. All right, my circle's not that great. Okay, but you can see it's a circle. All right, let's just extend this y out a bit here. So if we, oh, come on, just get straight here. If we extend this y out a bit, okay, perfect. All right, so now if we have a look and see, where are we? Okay, so we are in the third quadrant here. So we're actually going from here all the way around to here. Okay, that's where we've gone. Okay, we've gone all the way around, come here. Okay, so if we look at this angle, it's almost a revolution. So in terms of our diagram here on the side, okay, we are on here, we've gone all the way around. So if we want to find out where we are here, okay, if we have got an angle in here, in terms of our angles around the point, we see that this would be 360 degrees minus this angle theta in here. Okay, all right, so let's do our ratios for this thing. Okay, so if we sitting on here as our angle, right, just remember that this would be your opposite, this would be your adjacent, and this would be your hypotenuse. All right, so if we go ahead and fill in the values there, okay, we see that this would be, okay, from 0 to here would be positive x, okay, and from there to there would be negative y. So if we write our ratios in, okay, so sine of 360 degrees minus theta, all right, we'd see that we'd get obviously opposite over adjacent, which would be minus y over r, okay, which would provide minus sine of theta again. And if we had a look at cosine, that would provide, okay, positive x over r, which would just give us positive cosine theta, right? And if we had to evaluate the tangent here, again, we had to evaluate the tangent, okay, we see that the tangent in the fourth quadrant, okay, gives us opposite over adjacent, so it gives us minus y over x. Isn't that so? And that would give us minus tan of theta. Okay, so to summarize here, we see that the sine became negative and the tangent became negative, all right? And we see that the cosine became positive in the fourth quadrant. All right, so finishing this up, okay, we're going to have a look at a diagram to summarize all of this. That's called the cast diagram. Okay, it's called the cast diagram. So the cast diagram summarizes what we've just learnt right here. Okay, so the cast diagram aims to summarize the trigonometric ratios, behavior in all 4 quadrants. Okay, so we got one diagram that summarizes what we've just done in the previous slides in the video, okay, in the lesson. So if we start off with our Cartesian plane right here, okay, all right, and we understand, okay, so if we start off here, right, and we say this quadrant here is C, okay, let's first label, so 0, 90 degrees, 180 degrees, 270 degrees, and ending off at 360 degrees. If we start off here and say this quadrant 4 is C, this quadrant here is A, this quadrant here is S, and the third quadrant is T. Okay, so the A stands for all. Okay, the C stands for cos, the S stands for sine, the T stands for tan. Okay, so basically what it means, okay, in the first quadrant, okay, all the trigonometric ratios are positive. Okay, then if we look at the second quadrant, okay, what it means is that only sine, okay, is positive. All right, meaning that tan and cosine are negative. If we look at the third quadrant, means only tangent is positive, meaning that the sine and the cosine are negative. And in the fourth quadrant, we have only cosine to be positive, which then means that the sine and tangent are negative. All right.